So welcome to the second part. Um, Again, we're going to do a little bit more complicated integrals. So what if we want to integrate the idea of x squared over the square root of 1 minus x squared dx? Okay, how are we gonna accomplish our dreams or goals? Okay, well, again, always write down my substitution. Okay, so if I look at this, I have some number minus x squared. And what identity I'm thinking of? I'm thinking of 1 minus cosine squared of theta. That is equal to sine squared of theta. Well, I have a 1 here. So as currently written, my identity is valid. And so if I look at this, cosine squared theta maps to x squared. And so if I set those equal to each other, then this becomes x squared is equal to cosine squared of theta. If I take the square on both sides, this becomes x, and that is equal to cosine of theta. Well, what's my derivative? Well, because we found x, we need to find what dx is. Derivative of cosine is actually negative sine of theta d theta. Okay, so now that we have everything, all we gotta do is just plug in. So this becomes the integral, but what is x squared? That happens to be cosine squared of theta. Okay, what is d theta? Or what is dx? I'm sorry about that. Dx happens to be negative sine of theta, so this is multiplied by negative sine of theta d theta. And this is all being divided by the square root of 1 minus, well, x squared is cosine squared of theta, so this becomes cosine squared of theta. Okay, so there's our integral. Now if we continue, well, this becomes cosine squared of theta times negative sine of theta d theta. And what's my identity here? 1 minus cosine squared of theta is actually sine squared of theta under my square root. Okay, and so if I look at this, I could factor a negative out, so this becomes negative times cosine squared of theta times sine of theta d theta. What's the square root of sine squared of theta? That happens to be just sine of theta. Okay, and these are all being divided. Well, in this case, notice that my signs would actually cancel out because they're being multiplied. And so this now becomes the integral. This is now equal to negative times the integral of cosine squared of theta d theta. Okay, so this is all our integral comes down to. Well, in this case, we know how to integrate cosine squared of theta. We use its double angle formula. And so if I look at this, this becomes negative the integral of 1/2 times 1 plus cosine 2 theta d theta. Okay. And again, how do we get this? This is the double angle formula. And if we rewrite it on the side, cosine squared of theta is actually 1 plus cosine 2 theta divided by 2. Okay, so the only thing I did was just factor out the 1/2 in front, and you could see that this is also equal to 1/2 times 1 plus cosine 2 theta. 1 plus cosine 2 theta, okay? So this is double angle formula, and all I did was just factor out my 1/2. So I just wanted to let you know where I got this from, okay? And so now if I look at this, if I factor in my 1/2, my integral now becomes negative times the integral of 1/2 plus 1/2 cosine 2 theta d theta. Okay. Now, if I distribute my integral sign, this becomes negative the integral of 1/2 d theta. If I distribute my negative sign, I had to distribute my negative sign also. So this becomes negative times the integral of 1/2 cosine of 2 theta d theta. Okay. And so when I integrate this, this becomes negative 1/2 theta. Okay. Because we have, if we factor out a 1/2, we just have 1 here. So this becomes negative 1/2 theta minus 1/2 times, well, we know the integral of cosine of 2 theta. That happens to be sine of 2 theta, but because we have a 2 here, we got to multiply by 1/2 to cancel out that 2 when we take the antiderivative. And so the antiderivative cosine 2 theta is actually 1/2 sine 2 theta. Okay, and we just attach our plus c. Okay, so looking at this, the integral is now be given at 1/2 theta minus 1/4 sine 2 theta plus c. Okay, now we're not done yet. Okay, we're not done yet. And so if I look at this, well, what is theta? Well, going back to what we said earlier, we're always going to go to where we substitute where x is equal to. Okay, and so if I look at this, in this case, if x is equal to cosine of theta, that means theta has to be cosine inverse of x. Okay, and so if I look at this, my integral now will be given as negative 1/2 cosine inverse of x, because that's what theta is equal to. Okay, minus 1/4 times sine 2 theta plus c. Well, notice I did not plug in theta here, and there's a problem here. Okay, this sine 2 theta, we can't just say this is sine of 2 times cosine inverse of x. Okay, that does not work. That's wrong. Okay, so whenever you see this idea of sine 2 theta, here's the idea that we got to use. It's an identity. Okay, so we need to remember that sine 2 theta is actually equal to 2 sine of theta cosine of theta. Okay, so this is the identity we got to work with, and now you can see that we could actually plug in theta. Okay, so this is the identity that you need to remember. And so in this case, I'm just gonna go ahead and said, like in the earlier video, if you watched part 1, I'm gonna draw a triangle with theta in it. Okay, and essentially, let's make sense of this. They're asking us to plug in for sine 2 theta. We're gonna replace it with 2 sine of theta cosine of theta. Well, if we look at this, if we rewrite it, our integral is given by negative 1/2 cosine inverse of x minus 1/4 times 2 sine of theta cosine of theta plus c. Okay, now remember, theta is cosine inverse of x, and so if I look at this, or integral, you could rewrite this as negative 1/2 cosine inverse of x minus, well, if we look at this, this is 2/4. That's also could be rewritten as 1/2 sine, or what is theta? Theta is cosine inverse of x. Okay, and we're going to multiply that by cosine inverse of x plus c. Okay, so let's make sense of this here. The only thing I did was just replace theta with cosine inverse of x, which it is. Okay, so using the double angle form, using the identity, I just replaced theta with cosine inverse of x. Okay, now what do we know? We know that cosine of cosine inverse of x is just x. Okay, they cancel out to give me 1. We need to figure out what this is. All right, now remember what we said. They give us that cosine of the angle is x. Okay, and we need to find what sine is. Well, if we did not know, we treat this as x over 1. Okay, and so essentially, if we have theta, we know that cosine of theta is actually x over 1. So cosine is adjacent over hypotenuse. Okay, so cosine is adjacent over hypotenuse. And again, using the Pythagorean theorem, how do we find this third one? Well, we simply take the hypotenuse squared minus the other leg squared. And so if we take 1 squared, that's just 1. If we take x squared, that's just x squared. Okay, so again, the rule for the Pythagorean theorem, you just need to know. Okay, that's just simple stuff. So again, this is how I got this, the square root of 1 minus x squared. Okay, and so essentially the question is, if cosine of this angle is x over 1, what is sine? Well, sine is opposite over hypotenuse. So we know sine of theta in this case is actually 1 minus x squared over 1. Okay, again, we don't have to write 1, but it's there to know. And so if we know that is true, this is exactly what we're going to plug in for this whole term here of sine of cosine inverse of x over 1. And so In this case, the integral is going to be given by -1/2 cosine inverse of x minus 1/2 times the square root of 1 minus x squared. And we're going to multiply that by x, right? Because cosine of cosine inverse, those will cancel out to give me 1. And then the remainder I only have is x plus c. And this is our complete integral. Again, this is the answer. Again, some teacher will actually let you leave it in this form. Okay, I don't know why, but again, either or works. Okay, but I'm just showing you the complete answer. Okay, so again, this completes the second video. This is kind of a long integration, but again, hopefully it helps.